Well, a number of years ago we cloned the gene for a regulator of gene expression that has the unique profile that it is only expressed in a subset of dopaminergic neurons of the midbrain. And the interest of this regulator of gene expression is that it's expressed only or preferentially in the neurons that degenerate in Parkinson's disease. And so this regulator of gene expression appears to be a very good candidate for giving identity to those neurons, making them what they are. And part of what they are is the susceptibility to degeneration and causing Parkinson's disease. And so we're trying to use that angle, the role of this regulator of gene expression, as a way to understand the identity of these neurons, figure out how genes that are regulated by this regulator might cause the cell loss that is responsible for Parkinson's, and also to correct or to instruct cells into becoming the appropriate neurons in a perspective of gene therapy. Because if, as we believe, this regulator is part of the identity of these neurons, if we wanted to instruct stem cells to become dopaminergic neurons that you would use in cell therapy for Parkinson's disease, this regulator of gene expression is an ideal and required candidate because it gives the appropriate identity to the neurons. And we know from the pilot studies that have been done on cell therapy, transplantation in the midbrain, that those pilot studies are most successful when the appropriate cells were implanted in patients, as opposed to any generic cell that just produces dopamine. It's a long-term hope in the sense that we're looking for causes. We're hoping that this regulator really accounts for what makes those cells more susceptible. So in other words, we really want to understand the basis for the disease. But it also offers the hope of being useful in reprogramming cells, stem cells, for cell therapy. And the proof of concept is very good for these cell-based therapies. They've had quite striking success. We're just very in the early phases of trying to do that with reproducible success.